Okay, now this is part 2. So now you can actually watch as I push and make the spring go through. So I'm literally pushing with my hand, and hopefully you can see, I know you can't see a ton of it, and you can see the string bouncing back and forth, coming back to the same position, and you can see, if I push harder, you can see those strings come by through. There's something in my PowerPoint where you see a slow-mo video of this, so you can hopefully see it better. Alright, so if you draw, stop and pause the video and draw at the bottom of the page what you see. Alright, I'm going to assume you've stopped and paused the video. You should draw something like this, or you could draw with lines or coils, it really doesn't matter. But you should see that some of the lines are further apart and others are closer together as the wave passes by. Now I want you to turn the page and answer the questions 8 through 11 and start the video again when you've answered those. Alright, I'm going to assume you've tried 8 through 11, and question 8 says, how are they different? And hopefully you wrote something like this for number 8, that really it was how the medium moved. So with transverse waves, the medium moves across the line, so perpendicular to the wave as the wave goes down the line. But in these longitudinal waves, the spring was actually, the medium was actually moving parallel or in the same direction as the energy. So that's very different. So let me show you. So with a transverse wave, you can see it's constantly crossing that line. The spring is. But if I'm doing a longitudinal wave where I push, it bounces back and forth along that line. All right, on question 9, how are they the same? You could have answered several things there. But really, both waves carry energy from the same points, from one end to the other through the medium. And then the particles of the medium really don't move. They just kind of bounce in a different way, but they come back to the original position. And you also could say they all both just require energy to begin that vibration. All right, question 10. Hopefully you noticed with the blue string. The blue string just kind of, it didn't really move to another location. It just kind of bounced back or vibrated with that wave back to its original location. Now, on number 11, you are supposed to make some predictions here, which is really hard, I know, but just think about your picture. Think about what these words meant when we did transverse waves and see if you can figure out for longitudinal waves. Frequency, number of waves per second. Think about how we watched the green dot on the screen when we watched and counted as the wave went by in so many seconds. How do you think we're going to count waves with longitudinal? Wavelength, we measured crest to crest. How do you think we're going to measure some of those springs that were either closer together or maybe further apart? Somewhere in there is a wavelength. And then amplitude. Now, with amplitude, remember that requires more and less energy. So think again with amplitude, if I just kind of slowly push the wave down, you don't really see the coils coming together really strongly. But if I start putting a lot of energy to it, you see a lot of coils, a lot of dark spots there.